This
data into a
conference will now be recorded.
in data analysis, if you talk about human activities aimed at gaining some insights on the data analysis. Now, whatever you have organized your data and bring into appropriate format, now you are interested in gaining insights from that data through the analytics approach you are having. Analytics can be used, some data analytic tools, either tools could be used or some methods could be used, but principle here is to process the data and perform without special data processing approach. Next we have data analytics. Okay, now you, because analysis and analytics, so you analyze that particular data and various tools could be applied here to do the analytics on that data. Next we have the data mining, where you actually apply these data mining tasks to find it out the interesting patterns. So indirectly sometimes you have seen that these methods are being used one or the another way. Okay, so data science is data mining is a sub part of the data science, and then we have a two bifurcated domain which involves the data part, that is big data part, and the machine learning. Okay, so within that data science we make use of the machine learning models to mine the important insights from that data. So as I talked about the big data, it's a collection of the data sets so large and complex enough that it becomes difficult to process using hand-on database system tools or traditional data processing application. What does it means by that? Why we say any data to be a big data? Suppose I have a standalone machine with me. If I am unable to process a GB of the data on that machine, that for that particular system at an instance, that data is coined as to be a big data, because that machine is incapable of handling that data. Okay, whereas in general if you talk about, because in the market now various servers or racks based systems start coming into the market, we are able to process a huge amount of the data due to the capability of the machine has been increased over the period of time. So by the definitions, if you talk about, the traditional databases tool are become inefficient to be applied onto a current data. Okay, so that current data, if it is in GB, you are unable to apply the database systems tools or traditional data processing application or your standalone machine to process that data, then even the GB of data for you termed as a big data. Now, what categorizes to be a big data? For an example, I am a data scientist. I am working on a data. Which domain of the data I should work so that I can be categorized to be called as a the which category I should work in, so that you can say that I am working on a big data. Okay, so it involves actually involvement of 5 V's. One is called as volume, variety, velocity, veracity, and value. Okay, so 5 V's. Now I think so over the period of time they are working on more V's. So might be within an year 7 V's will also come into the market. So they are looking at the different dimensions of the big data, and each of the dimension has give an new directions to evolve with a new V. Okay, so here we see earlier it used to be a 3V, then 4V, and then later on analyzed with 5 dimensions of the big data. So here if you talk about, the first one is called as volume. So suppose being a data scientist, you are working on a data which is huge in volume. Okay, volume in the sense it could be in zettabytes, petabyte, or trillion gigabytes, like here it's shown. By 2020, accumulated digital universe of data will grow from 4.4 zettabytes today to around 44 zettabytes. Okay, so from 4.4 it will go to 44. Okay, and then 44 trillion gigabytes. So this is what digital universe data will grow. They have an estimate over a period of time. So even if you are dealing with a huge volume of data which is big in terms of volume, okay, that is also termed as a big scientist working on a big data domain. It's not like that you have to work in all the 5 V's dimension. If you are working in just one of the V and dealing with data, handling the problem in one of the dealing with one of the view of the big data, then it is termed as a handling big data problem. Next is called as the variety. Different kind of data is being generated from various source. Like for an example, Twitter, every tweet which you are keep on doing will have a different format. Similarly, you keep on posting the message on the Facebook and WhatsApp will have its own format. So based on different platforms, will have different ways of taking their input, we have a different varieties of the data is being generated. And we have seen also structured, semi-structured, unstructured, quasi-structured data is being generated. So in structured databases, if you talk about, we were mainly dealing with the relational databases. In case of semi-structured data, if I talk about, these this involves JSON file, XML file, CSV file, and so on. And unstructured data, you might have audio, video. Like for an example, best example I could give it for this is, it could be a WhatsApp also, where you keep on posting your audio messages, video messages, images also, and logs are also being generated. So due to this different varieties of data, if you are molding the data, like you have taken the unstructured data and bringing that data from unstructured format to an structured format, then also you are dealing with one of the V's of big data. Then it is also termed as you are dealing with the big data. Further proceeding, next we have the velocity, the speed at which data is generated. Okay, so data is being generated at an alarming rate. It's like you can see here, every 60 seconds, 98,000 tweets get generated. Okay, and 11 million instant messages are being generated. So if you see here, big data is soon to be scaled to exabyte. Okay, like this it is keep on growing, because now technology, due to the evolution of the technology, devices are getting cheaper day by day. Okay, everybody is replacing the cell phone within a year or two, or some are interested in replacing the cell phone every 5 or 6 months, like so. And everybody is now connected to the internet, whether the educated person or it's not very educated enough, somehow they are in get very in somehow they are very familiar with these social networking platforms. Okay, and they are also start keep posting the various messages, videos, and so on, because accessibility to each and every citizens of the country or the world, if you talk about, everybody is making use of this platform, and data is generated in with a huge velocity. Earlier, if you talk about, the velocity is not at an alarming rate, but right now it is an alarming rate. And by the time, if I everything or the appliances of the home start connected to become IoT enabled devices, if you coined this term to be an IoT enabled devices, then lots of data is generated. For an example, right now many of you are using refrigerator in your home, which is not IoT enabled device. Okay, but over the period of time, if you purchase everything what comes in the market and an appliances, if everything is connected to the internet, then what will happen, all these devices also start generating lots and huge amount of the data. So the velocity again, velocity of the data generation of the data will leads to a further alarming rate. Okay, so further proceeding, next fourth V we have, which is called as veracity, on uncertainty or inconsistency in the data. Okay, for an example here, some of the data which you are generating, at the time of the generation you are just accumulating the data, you are not seeing that data, whether that data is useful or not, but you are generating that data. And while generating that data, some of the informations might be missing, so you are actually interested in um, correct that data. Okay, so whatever the uncertainty is there, you are interested in eliminating those uncertainty. Next we have is called as the value. So mechanism to bring the correct meaning out of that data. It means that whatever the data you have and the insight you want to get it from the data, the exact information are able to get it from the data after doing all the processing. Okay, so you are interested in certain values, whether that information is relevant to you. Okay, so that is another V. Okay, so what values you are getting out of the data for your analysis leads to a one of the V, and that is also one of the important dimensions of the big data. So if I talk about here, all the five V's are being shown over here. So if one of the V you are dealing with it, okay, it will be termed as that you are working in a big data domain. Next is the big data analytics. So now, because you have big data, due to the evolution and being bifurcated into 5 Bs right now, okay, we have to perform the analytics over that data. So to perform the analytics, what you are actually interested in big data analytics involves examining large and different types of data, in the sense structured, semi-structured, quasi, and unstructured data, to uncover the hidden pattern, correlations, and other insights. Okay, Correlations in the sense like Amazon or Netflix. For a good example for this could be a Netflix. Like for an example, Netflix has accumulated the data, and it has accumulated the data that most of the users who are right now watching the movie on the Netflix are in the age zone of nearly 30 to 45. Okay, for an example, or for an example, uh, 20 to 40. Okay, now what I should do so that I can attract other age group people also to the Netflix. Okay, so they want to drive a correlation by this. Okay, so for that they keep on posting, suppose for an example, an old movie, or for an example kid related movies. Okay, and then see okay, this one person is joining, and over the period of time, because if I upload more related videos which are getting favorite day by day, if I upload more related episode related to that, most of the age group people start joining, and this will leads to an increase of the customer base. So this kind of correlation from just posting one of the seasons of a particular, just one episode of the particular web series, if I find it out that I'm able to attract these many customers, now I have to put more web series related to this kind of web series interest. Okay, I can attracted more customer to my Netflix domain. Okay, so like this I'm interested in finding out from the huge data that these are the uncover hidden patterns which I could be interested in. So need for big data analytics is required in making smarter and more efficient organization. Okay, so for example, good example shown over here is New York Police Department is utilizing data patterns, scientific analysis, and technological tool to prevent occurrences of the crime. Okay, so uh, for an example, they have planted cameras everywhere, and now before the accident happened, they are analyzing and making use of the big data analytics, you can say mining techniques onto the data, and analyzing the big data in such a manner so that hidden patterns could identify. For an example, likely in the evening the crime is about to happen in these many areas. Every time by looking to that pattern, they collected the data from the cameras and the other domains. Okay, and then they analyze that data and find it out interesting observations that these areas where I might be the electricity street lights are not there, likely these are those areas where the crimes is about to happen once in a month, or twice in a month, or twice a day. Like this these types of crimes happens. Okay, so New York Police Department is actually collecting the data from various places where they have actually implanted the cameras, especially risk areas. Okay, and then they are analyzing what's the time and what are the key factors due to which these type of crimes happen in these areas. Okay, so that they can make use of these technical tools, so that near future if more crime is about to happen, they can actually make send an alert to the send an alert or to the citizens, as well as they can prevent those crimes to be happen in that area. Need of big data analytics for the second scenario is optimize business operation by analyzing customer behavior. The best example is Amazon or the Flipkart, if you talk about. Okay, so Amazon uses customer click stream data. Now, in this case, the customer click stream data they meant about is the way you traverse actually the Amazon web page. The first you log into the Amazon website or open the Amazon website, and which tab you are clicking in. Okay, so in that manner they are analyzing the entire, you can say, tracking your entire click streams. Okay, so like for an example, how you are navigating from one tab to the another tab, and by navigating all of the tabs, and how you are exiting from the Amazon website. Okay, so this will give them the analysis that the customers are actually leaving the Amazon website without buying anything. If this is the case, then what they do is they actually try to improve the customer base. They are interested in that. So based on historical past purchase data, okay, how or for an example, they also analyze in that sense. Suppose I'm the person who opened the Amazon website, and every time the style I used to click on one tab to the another tab, they have analyzed my click stream data, and they have seen a pattern that most of the time I buy. Okay, and sometime might be happen कि the website which you have designed might not be of interest to the user, due to which what is happening, the person is visiting your website but not buying anything. Okay, are not buying anything. So in that case, they are actually looking to this feedback based on your clicks. Okay, these feedbacks are feedbacks in the sense they are looking your click stream, so that they can actually modify the Amazon website so that more customers could be attracted, and they should not just leave the website by just visiting it. Okay, they want to design a website in such a manner that you click onto the add to cart page and buy the item and then only leaves the page. Okay, so Amazon uses click stream data and historical purchase data of more than 300 million customers, and each user is shown customized results only. Like for an example, earlier when you this Amazon and Flipkart website has been introduced, these recommendation systems are not so fast enough. Okay, whatever you are buying, you just buy and log out from that website. But right now, whenever you buy, they keep on giving the recommendations very soon. Okay, so what is happening, even though you are not interesting, but you see certain things which might you want to buy it in the near future, but you like it very much, so at that time, rather than buying just one product, you buy two products. So this is the way they increase their sales as well. So analyzing all clicks of every visitors on the website, studying the path, okay, to buy the product, whether it's satisfying the customer or not, accordingly they are making the modifications in the website also. Okay, some of the websites, when you go to the any shopping website, you don't find the website interesting. Okay, so that is one of the reasons that does not attract the customer. So this click stream history basically led them to improve their website as well as customer base. Third point is need for big data analytics in the cost reduction. Okay, so you want, okay, whatever you are doing, you want that cost should be reduced. Even like for an example, whatever the big data is being emerged into the market, I'm unable to process that with the standalone machines. Okay, if I go for purchasing a high end machine, that will also increase the cost. Okay, so can I have certain tools like so that if using them, I can able to process that my data as well as cost reductions could be done efficiently. For an example, Parkland Hospital uses analytics and predictive modeling to identify high risk patients and predict like outcomes once a patient are sent to the home. Okay, for an example, this you can consider in case of the COVID scenario. Like most of the doctors are started giving the online assistant also for any diseases which does not have a very severe medical emergency to be investigated physically. Okay, so Parkland Hospital uses analytics and predictive modeling to identify those patients if they are about to having a high risk kind of disease, and predict likely outcomes once a patient is sent to the home. For an example, in case of here in India, you can see, suppose you are going to any diagnostic center every month, for an example, for your sugar diagnostics or a blood test, every month they keep on sending the reminder like so that you you have not visited to the lab. Okay, because this at this time you are scheduled to be visited to our lab. Okay, so what is happening in this case, they are actually increasing their base as well as sending us the reminder. And if I'm unable to actually go to my visit, I can inform that diagnostic center to arrange at a I can inform that diagnostic center to arrange the medical diagnosis at the home. So this can be done in certain diagnosis centers. So as a result, Parkland reduced 30 days readmissions for the patient with heart failure, and by 31% saving. So this much is the money they have saved efficiently. So they informed a bit prior. So like this, using big data analytics, predictive models, they actually increases the actually perform the cost reduction. Next is the next generation products. So big data analytics is also useful in terms of the next generation models I talked about earlier also. Like for an example, self-driving cars, okay, or you can say driverless cars. Basically, these are enabled with the IoT enabled devices. So big data tools are used to operate Google self-driving car. The Toyota prices is shifted with cameras, GPS, as well as powerful computers and sensors to safely drive on the road without the intervention of the human being. Okay, so driverless cars are being efficiently running in some of the countries, but might not be in India. Okay, so this leads to a generation of the new product into the market which does not needs a human intervention. Similarly, Netflix launched a season of its TV show House of Cards based on user review, rating, and viewership. Okay, so for an example, customer the for an Netflix who has collections of certain movies or the web series. Okay, but certain programs which is being liked by most of the young age people, and these are the major customer base of the Netflix. What they do is they based on but they have the customer data with them, they start launching the new seasons, okay, onto the Netflix domain, or they start launching seasons of its TV show House of Cards like that based on rating, reviews, and so on. So next generation like this products could be emerged. Similarly, smart yoga mats is also there, okay, which has a sensor enabled in the mat, so that if you are making a wrong posture while doing the yoga practice here at your home, they basically alerts you. Okay, so in this mat, you are being able to provide a feedback on your posture, score, practice. Okay, like this. And for an example, right now, many of them are start using the smart watch. Okay, which keeps on counting your steps. Okay, how many steps you are taking in a day. Okay, so this keeps a track how much you walk a day and how much calorie you have burned. So these kind of the lots of data is being generated because lots of sensors are there. Okay, so these are the next generation products which emerge into the market, and there is a need for the big data analytics. Okay, like in case of the sensor based car, if you talk about a sensor, this driverless car, sensors are being implanted over there. So if the sensors are generating lots of data, and this lots of data is being accumulated at certain place. Okay, so once you collected the data, you want to analyze. Suppose in a driverless cars, accident happen for a certain scenario for which this car is not being trained with. So how you will improve the performance of this car? You will analyze the entire data, and especially that incident, what time the especially at that incident, what data is being collected. So based on that data, you again train that car so that your car will be free from the human intervention and less susceptible to any kind of accidents. So big data is an opportunity, even though it has many challenges. We have a various opportunities also over here. That cost effective storage solutions we require to process huge amount of the data. Okay. Earlier, if you talk about the servers which comes into the market to process this huge data, they are very you can say very costly. Everybody is not able to afford that. But right now, cost effective servers also start coming into the market. Okay, so that you can process such a huge amount of the data. Okay, similarly, automated acts as big data next generation products emerges into the market, automated car come into the market, healthcare systems. It also created many opportunities in the healthcare domain. You analyze lots of amount of the data and generated a solutions for these domains. So in various domains, especially in business also sectors, even though the data generated is huge, but you come up with a better decision making. Like in case of Amazon, a better recommendation systems start coming, and you get recommendations so fast that you cannot even analyze quickly. So I am going to discuss here the various use cases which involves uh, making use of you can say IoT enabled devices which collects the huge amount of the data and making and analyzing, getting important insights from that data. Okay, so earlier in the houses I have talked about that we have a manual the meters fixed in where a person comes at the end of the month, collected the reading and generate the bill. Okay, but right now IBM introduces a smart meters which collected the data in every 15 minutes and send the data. Okay, now because it is sending the data in every 15 minutes, that time that person used to come and collect the data in a month. Okay, so one reading corresponding to 1 meter hardly. Okay, so here what is happening from a single meter with in a 24 hours, you can imagine how much data is being generated within a 15 minutes. If one reading is being sent or the current reading is sent, next again send it 15 minutes, within an hour 4 times our data will be sent. Okay, so this leads to a generation of huge data from just 1 meter, and we have lots of the electrical meter fitted into various house. Especially if we talk about India, we have 135 crore population. So if you talk about everywhere electrical meter, if we fitted it off and they are sending the data, huge amount of the data gathered at electrical substation databases. So managing the large volume and velocity of information generated by short interval reads of smart meter data can overwhelm existing IT resources. Okay, so whatever the databases, warehouses they have to store that data will be exhausted. Okay, they cannot store much amount of the data. Okay, then we need some important pre-processing pre-processing in the sense to analyze important insights from the data. That those methods are required so that intelligent recommendations could be given and data could be managed efficiently. Okay, so now in this case, what interesting insights they might be interesting in, that 96 million reads per day for every million meters is being generated. Now, big data collected from this smart meter leads to a problem that so much amount of the data is being generated, but there could be certain scenarios in which whatever the data you are gathering will bring out the important information for their customers also. Okay, so we will see. So problem with the smart meter is to manage and use this information to gain insight. Okay, and utility company must be capable of handling such high volume of the data. That's what I said, that these company, suppose for an example, Bharat Electronic Limited, okay, or any power substation, power based companies, if you talk about, they have implanted their meters. They are hardly collecting one unit corresponding to one reading corresponding to one house. But right now, because of this electric meter, whatever the company is providing the electrical connections, they have to be very sound enough in terms of the storage, because every 15 minutes data being gathered from one house, you can imagine how much data is being gathered within a one day and 30 days. Okay, and corresponding to the population also. So be capable of handling huge volume of data management, advanced data analytics designed to transform data into an actionable insight, so that you can transform that data into importing insights which you are interested in gaining to it. So storing is one of the problem, and then and how you will analyze that is the another problem. So how the smart meter is being analyzed and what they are analyzing is the important thing to be noticed here. So before analyzing big data, this is a scenario before utilizing big data and after analyzing the big data. Okay, so before analyzing big data, energy utilization and billing has increased significantly. Now, what is happening? Because I'm not aware in which timing these hours are the peak load times and which hours are called the off peak times. Okay, because I don't have the smart meter implanted over there, I just go and collect the reading and generate the bill, and might be for entire unit of the bill being generated, the same unit charges, I being a provider, I kept a same unit charges over there. Okay, but right now, because this smart meter is being implanted, what I do, because I'm collecting the data for the every 15 minutes, I can bifurcate that data into two parts. One is the daytime I am making the collection, and the night time, which I called as a off peak time, I'm collecting the data. It means that how much is the amount of electricity being utilized in a certain area, which is a residential area, and how much is the electricity being utilized in a off peak time, especially in the night. Okay, after suppose for example 10 p.m. to 6 a.m. Okay, like this. So what I do, I will check out, okay, this is the utilization, so accordingly what I can announce is, rather than making use of all the appliances in the day hours, that is a peak load hours when maximum users are using their most of the appliances in the home, like so, I can give the you can say offer or the facility, like so, if particular these kind of the appliances, if this much electricity usage will be used in the morning and this much will be done in the night charges will be a bit low as compared to the morning charges. Okay, like this what will happen, first of all I will able to manage the load efficiently. And similarly, if you have certain factories also implanted near to that area, accordingly I will intimate the factory persons to work on a off peak hours. So in those peak off peak hours, the electricity will be provided at a minimal cost. Like this, what will happen? Load management will be done efficiently, as well as more customer. You can say more customer will join to a certain provider. Okay, because charges are varied. Okay, earlier for whatever the usage, whether it is in day or the morning, the bill comes out to be with the same billing units. Okay, so time of use pricing encourage cost savvy retail like industry heavy machines to be used at a off peak hour. So these are the kind of analysis I have come up with the smart meters being implanted over there, that which area is making use of how much utilization, so that this certain grid will not get faulty, okay, due to the overutilization. These kind of precautionary measures also could be taken into account well in advance, because I have data collected every 15 minutes. So IBM Smart Meter Solutions here is IBM offers an integrated suite of product designed to enable IT to leverage big data in a varieties of way that contribute to a success of energy company. Okay, so first what this IBM is doing is data warehouses they have created. Once they collected the data, they have to make sure that the data security should be maintained. Okay, and reporting should be done time to time. That data should be reported, and then accordingly analytics will be performed, and then data mining will be performed, and then analytics will be performed on that data. Okay, so managing smart meter is one of the most important tasks when you are implanting these kind of the smart meters, that they should work properly, okay, and could be fixed into every houses. Apart from that, monitoring of these grids should be done. How you are doing the monitoring is that you are collecting the data time to time. Okay, so like this you are monitoring the data, that certain area is making overutilization of the power, so certain grid should not get faulty. So before that, due to your monitoring, you are taking a certain suitable steps, so that these kind of disturbance or these kind of, you can say, power cut should not happen. Okay, simultaneously you are optimizing unit commitment also, and saving optimizing energy trade also. So what is happening, because varied charges, most of the people who are making use of most of their appliances in a particular peak hours, now they start using their appliances, especially like for an example washing their clothes with a washing machine. Okay, they can do it in a night time also. Like this, optimizing energy trade could also be done. Forecast and scheduling loads also. So accordingly I can schedule the loads, because this is smart meter provide which area you making use of the you can say power in a particular hours. So accordingly I can make a forecast also, that due to the heavy usage here, okay, likely this grid is going to be get faulty. So accordingly I had to schedule load in such a manner, so that these industry should get a power in that particular hour, where things will be settled down. And mostly the commercial people, if you talk about the residential people who are making use of the electricity, will not get but will not get into a trouble. Okay, so like this I can schedule the load. So here one of the very well known companies, Encore, who are working who are using basic who is basically a provider of the electricity and making use of the IBM smart meters. So this is one of the well-known company, and this is the biggest company in the Texas who are involved in this electricity providers. Who is one of the basic major electricity providers. So Encore Electric Delivery has incorporated IBM smart meter service, which involves three tasks, that is instrumented, interconnected, and intelligent. Instrumented utilize smart electric meter to accurately measure the electricity usage of the household. So they want these IBM smart meters should be integrated uh, correctly, okay, so that accurate measures and reading should be given. That happens many a time that they integrated the meter in the house. Some of the customers keep on complaining to the electricity department that these many units of the whatever the bill obtained by your electricity department, this much electricity I have not consumed, because I am out of town, nothing, no, none of the appliances is working at my home at that time. So if they want to make sure that it should be instrumented properly. Interconnected, that unprecedented access to denial information about their electricity usage. Okay, so it should be interconnected very well, so that if electricity usage is going above the bar, okay, you can prior make an arrangement so that such kind of fault should not be happen. Okay, intelligent customer monitor and control their electricity usage also with that smart meter through near real time reading of electric meter. Okay, so the reading should be in such a manner customer should also be able to monitor how much is the usage happening, okay, in the peak hours and the off peak hours, so that I can calculate, okay, how I can monitor my expenses of the electricity. So customer in Encore service territory showed last year during the company biggest energy savers contest. So that by using the information of Encore advanced meters. So by implanting these smart meters, they becomes a very good provider in the Texas, and also saved lots of the energy, okay, and also provide the energy at the reduced rate, so users reduce their electricity usage and bills by 25% or more. Like this they are getting benefited with the advancement of the smart meter being integrated, provided by the IBM. So next stages in the big data analytics involves now, because we have various use cases we have seen, where we are collecting the data and can utilize that data to come up with the important insights from that data. Now how you make the analysis of that data is also an important task. Okay, so first, for any problem or any domain you are working in, you have to identify whatever data is collecting, what is the problem for which you are looking towards the solution. So identifying the problem, designing data requirement, and then pre-processing the data, because various platforms which are working, for an example retail websites which are working, they are collecting the data, but not every data will be useful, so they have to pre-process the data and bring that data into a required format, okay, and then perform the analytics over that data, and then have to apply certain tools or the graphs to visualize that data, so that interesting insights could be bring up in terms of the graphs, okay, because that are easy to analyze, okay. Like for an example, in case of smart meters which I have implanted, I can come up with a trend that in a night this is a uh, distribution or usage of the electricity, and in the morning hours these are the particular hours in which most of the appliances in the houses are being in the running mode, so these could be termed as the highest peak hours where energy utilization is maximum, and these are the low peak hours where I can regulate, okay, I can regulate in such a manner so that such peak should not be arises, okay. So type of big data analytics involves, now because you want to analyze the data, that involves various steps. One is called as the descriptive analytics, second one is the predictive analytics, next is the prescriptive analysis, and fourth one is the diagnostic analysis. So in case of descriptive analysis, what is happening now based on the incoming data? Google tool is the best example of descriptive analysis. A business gets results from the web server through the tool, which help understand what actually happened in the past and validate if a professional campaign was successful or not based on the basic parameters like page view. For an example, in this for this specifically, we will take a real life example. Uh, every time, whenever the elections come, okay. Certain campaign is being launched, okay, and then a certain party will win, and they will launch the campaign through various social networking portal for an example, coming up with the campaign tagline, posters, okay, or the comments in that, text in that, they hire a particular professional, okay. Now they want to see that how much is the contribution of that campaign, whether the campaign is successful or just I wasted my money just wasted my lots of money in that campaign. Although does it brought any significant contribution towards my towards winning the election, okay. So this is a kind of descriptive analysis in which I am interested in, which will validate if a campaign was successful or not successful based on certain parameter, that is how much, suppose that campaign related to a certain party, I have posted it on a social networking site, so does it receives, you can say, does it being liked by the people, not liked by the people, according I'll make the prediction that in this particular area where I'm able to win this much seats or not, because based on the liking and unliking I can make such kind of prediction, and this is how you can say somewhat these AASTAK and ABP news keep on doing, even though they go and personally take the suggestions from a huge sample of a population, okay, but this is the one of the way through various campaigning posters they can identify that this campaign is being successful or not, being posted by a certain political party. Okay. So next is the predictive analysis. Okay, so what might predictive in the sense you will predict in the future. Okay, so what happened in the future? For an example, Southwest Airlines analyzes sensor data on their plane in order to identify pattern that indicate potential malfunction that allow airlines to take a necessary action before it's scheduled. So every time whenever a airline is being scheduled, everything is being investigated very properly. In spite of that, you have heard about many plane crashes happen, or even the flight has taken a takeoff. At that time only a certain emergency happen in that. Okay, so predictive analytics basically involve in identifying such kind of hidden patterns by implanting the sensors, so that you analyze whatever the data collected from sensors, that these kinds of fault occur when we have our data collected showing the patterns like so. Okay, so if these kinds of pattern again emerge which are likely to be identified, resembled with those pattern when we likely had certain kind of mishap happens. Okay, so these kind of malfunctions could be potentially protected before it can happen. Okay, so this is how predictive analytics is being, you can say, taken as a precautionary measure. And then we have a prescriptive analysis, where a good example is called as the Google self-driving car is a perfect example of prescriptive analysis. It analyzes the environment, decides the direction to take based on the data. Okay, like humans also met an accident. Similarly, self-driving car, or you can say driverless car, basically also will met an accident, but it will improve based on what data it being collected and data collected by the sensors, and the chances of accident being claimed by the self-driving car is bit, mostly likely nil sort of. Okay, because it has been intelligently being devised. While designing also, lots of testing has been done, so that all the possible cases could be integrated, because this does not include human interventions. Okay, so whenever it has to be, you can say, come onto the on road, okay, it has to be integrated with all the possible cases. Okay, so prescriptive analytics is one of that examples. Next we have the diagnostic analysis. Why did it happen? For an example, social media marketing campaign, you can use diagnostic analysis to access the number of post mentioned followers and analyze the failure or success rate of the campaign. Similarly, in case of descriptive analysis, I will basically describe how my campaign is successful. So here, based on how you suppose your party will not win the election, then you can make the analysis using diagnostic analysis, that these are the possible reasons of my failure, by looking to the comments being posted on a certain particular social networking site related to that campaign. What are the possible cases which public don't like? Okay, or what are the possible your failure party failures is which a public does not like, and you have not addressed in that campaign also. Okay, that I'm going to improve this. Okay, so this is a kind of diagnostic analysis which will be done through these social networking platforms. Okay, now because you have big data, there are various problems in the big data, that how you will store such a huge amount of the data, because data generated in past 2 years is more than the previous year history in total. Okay, so as I told you, most devices will be IoT enabled, lots of data will be generated. Okay, because in abroad, if you talk about the other countries, they are start using making use of the IoT enabled devices. But right now in India, if we talk about, not all the appliances are basically IoT enabled, but right now it start coming into the market. Okay, so once every person is making use of the IoT enabled devices, then lots of data will be generated. So by 2020, total digital data will grow to 44 zettabytes approximately, and by 2020 about 1.7 MB of new information will be created every seconds for every person. So this is a kind of data we will be having, and that will leads to again problem, that how you will store that data, how will you analyze that data. Next is processing data having complex structure, specifically when you have unstructured data. Okay, how you will process that data? Even you have the structured data, if it's a huge in volume, how you will process that data? Third is, once you find it out that you will able to store the data, you will organize that data into a particular way so that you can process. Now how you will process that data is another problem. For that, now a scalable, you can say, platforms start coming which scale down your data to the multiple systems. So here you can have an example here, like you have a master node here, okay, which stores the data and try to you can say distribute the data across these slave nodes, okay, so that you whatever the task has to be done alone onto the master node. If I you can say distribute the data onto the slave node, whatever the computation capability these slave nodes will have to handle that data, and I deployed that algorithm onto those slave nodes, so whatever the results I am computing on a master node could be parallelly be done onto the slave node, and then this could be communicated back to the server node or the master node. So this is how you can see capacity in megabytes the data is being generated over the period of time, and the by making improvement in the performance of the systems. Okay, earlier standalone machine does not have that much of the hard disk and the RAM, but right now the server or the rack based servers which keeps on coming into the market, even you can have afford to have a 250 GB of RAM, 500 GB of RAMs also. Okay, so Hadoop is one of the solutions to face all the problems which lies in the big data. So Hadoop is a framework that allows us to store and process large data sets in parallel and distributed manner. So it includes two basically called as subunits, which is called as the HDFS, Hadoop Distributed File System, and MapReduce. So Hadoop Distributed File System is basically responsible for storage of the data. Okay, so allow to dump any kind of data across the cluster here in the sense, suppose this is a master node and these are the slave nodes which grouped into the cluster. So I will called it as a Hadoop cluster which I have created it out. So it is responsible, Hadoop distributed file system, that how you will distribute whatever the data is held with a master machine, how you will distribute that data onto a multiple you can say slave nodes, so that they can process the data efficiently, and then within a same time span everybody is processing the data in a parallel manner, and then can give the data back to the master node. Now how you will distribute that data will be done by the Hadoop distributed file system. Okay, so and then mapper and reducer are being responsible that data once I have distributed among the slave nodes, there will be a mapper functions who will actually perform the computations onto that data. Okay, and for every computation I will create a particular mapper program, and once the execution is being complete, you can say a temporary buffer which I have created, which is called as the RDD, which stores the result onto the every slave node, and then slave node will send the data, and this is stored in the RDD. So multiple replica of RDD will be created, so that if this particular slave node get failed, that RDD will able to send that data back to the master node. Okay, so that is called a resilient distributed databases. Okay, so map reduce its joint function, you can say we have a mapper program running parallel onto the various machines corresponding to a particular data being sent by the master node, and reducer will be responsible for accumulating the results of all the data corresponding to various map functions being simulated onto the multiple machines, and will send the data back to the server machine or master machine. Allow parallel processing of the data stored in the Hadoop distributed file system. So Hadoop distributed file systems creates a level of abstraction over the resources from where we can see the whole HDFS as a single unit. So entire this could be termed as a one cluster, which consists of a master node or the slave node, or called as the name node or the data nodes. Okay, so name node is the main node which is responsible to hold the data, and Hadoop distributed file system is responsible for distributing the data across various data nodes, which are commodity hardwares in the distributed environment. So, storage unit of the Hadoop uh, is a solution corresponding to the HDFS. It's a distributed file system. It's divide the input data into smaller chunks and store it across the cluster. So this is one cluster. You can assume that okay, I have 512 MB of file which I am unable to process onto a one machine. Then what will happen? Hadoop distributed file system will segregate this data parallelly onto the multiple machine. Suppose for an example, 128 MB of data on this, 128 MB of data on this, and then at the backend side there will be a RDD, resilient distributed database, which will store the results of each and every you can say slave node in this case might happen certain machine do the computation bit faster, because it's not necessary that all the machine in a cluster should have the same computational capability. Only that much is required so that this can support the Hadoop distributed file system. It might happen this machine would have a processing RAM of around 125 GB, but this machine could have a RAM of 64 GB, but it is compatible, okay, with Hadoop distributed file system and supporting the server machine to be a part of the HDFS. Okay, so then the processing of this machine could be a bit faster as compared to this machine. Then it can hold the data till the jobs of all the machines get done. And then once the job of all the machines get done, RDD is basically responsible for sending the data back to the server node. So allowed to store any kind of data, be in a structured, semi-structured, or unstructured format. So HDFC is Hadoop distributed file system is not bounded to a particular kind of structured data. It can store any kind of data, whether it comes on a XML file, JSON, or audio, video, like so. Follows warm, write once, read many. Formula it works on. No schema validation is done while clumping data. Okay, so schema validation, like which kind of particular relational databases schema it is following, or which kind of storage structure it is following, that validation will not be done at the time of storing the data onto the Hadoop distributed file system. So with Hadoop distributed file system, third major advantage is processing data is faster, because once you process the entire 1 GB of data onto one server machine, this will take 4 hours. And when you parallelly process that data onto a various slave nodes, this can be done just in a 1 hour. So every node will respond within that 1 hour, and the entire job which we are doing just with the master node in 4 hours could be done just in 1 hour. So allowed to process locally, and each node works with a part of data which is stored on it. Now, what are the tools used in the big data analytics? Apart from the Hadoop, there are many tools. Now, like I told you, specific to the application, what kind of the analytics you want to come, or the important insights you want to come, depends as per the application to application. Similarly, Hadoop distributed file system is one of the platform to process the big data. Apart from that, there are many other platforms comes in the market based on your requirement. Okay, for an example, another platform which is called as the Apache HBase. Okay, no SQL databases, which is called as, another one is the Apache Spark. Okay, so apart from Hadoop, there is another platform which is called as Apache Spark. Currently, if you talk about in my research domain, I'm making use of the Apache Spark. That's based on in-memory computation. I don't want everything I stored onto the hard disk, then it has to that data brought into the main memory, and this hard disk to main memory, you can say transfer of the data takes lots of amount of time, especially in the big data. So Apache Spark works on a in-memory computations. Whatever the data here held with you should be kept into a current memory, or the main memory you have, not in the secondary storage. For that, you require your main memory should be huge enough in the size. Okay, and then that input output operations does not take lots of amount of the time, and the results could be analyzed in a much more faster manner as compared to the Hadoop distributed file systems. Okay, like this, there is another, apart from which I have mentioned it over here, there is another big data analytics tool which is called as Giraffe, which is specifically using if you are working on a graph based algorithms. Okay, so specifically with the different types of problems you are working, you have a different analytics tools. Like for an example, in my research I make use of Hadoop. Okay, for processing 12 GB of data, it took me nearly a week. Okay, but while processing it with the Apache Spark, it could be done just in half an hour. So this is a kind of small big bifurcation you can see. Even you can use Hadoop distributed file system for the other specific applications or the problems, but the performance you are getting with that might not be that much good, specifically for graph based algorithm if you go with this Apache Giraffe. So based on the different tools, these are the bifurcation. Like I told you, every tool is designed with a specific need. So Hadoop provides a scalable solution to store, process huge data in parallel and distributed fashion. Similarly, Apache Hive is a data warehouse tool which is responsible for accumulating a huge amount of data that allow us to perform big data analytics using Hive query language. So whatever you are writing have to be written in terms of a Hive query language. Apache Pig is a platform which used to analyze large data representing every problem as a data flow. Okay, whatever you have a problem, that has to be represented as a data flow, and then data flow will be processed onto the Apache Pig platform. Apache Spark, like I mentioned right just now, it's based on in-memory data processing, so it's much faster as compared to the Hadoop distributed file system that allow us to efficiently execute streaming, machine learning, SQL workloads, and require fast iterative access to the data set. And next is the Apache HBase, which is a non-SQL database that allows store unstructured, semi-structured with ease. So with unstructured and semi-structured, if you used with another platform, might not be that much efficient because those platforms are not designed for taking into consideration those particular structure of the data. But HBase, Apache HBase, if you use, this could be a more efficient platform specific to a particular data you have. Okay, so these are the tools which you can use in terms of big data analytics. And especially, like if I talk about in my research, I'm making use of the Apache Spark. So these are some of the work which I have done based on the big data analytics. You can refer to the web page or the Google Scholar page, where you can find some interesting work done in a big data domain, and specifically integrating the machine learning algorithms to perform the data analytics part, especially on the big data in genome bioinformatics area or genome data analytics area. So I rest my lecture here, and welcome for any questions if you feel that there is any questions in any of the slides you have.
Hello, ma'am. Can you
Yeah,
show that slide on which you had shown the difference of data science and data
yeah, sure, sure.
analytics
Yeah,
analysis?
yeah.
Could you explain that once again? Like, is data mining, um, how is
Yeah, this
data
is the
mining
slide.
and big data analytics related?
Big data analytics, like here in this you can see data analytics is a general analytics where all the basic tools of the analytics could also work. But in case of big data analytics, if you talk about basic analytics tools, like for an example, R language, if I'm using on the data analytics, might be on this small data, R language tool will be workable. But that R language tools I cannot use in case of the big data because it will not able to process that data. Even in case of MATLAB, because I practically encounter. Can you please switch off your mic for a while? It's create a lot of disturbance. Yeah, it's completely fine right now. Like in case of big data, if you try to work on MATLAB, okay, it gives you a memory segmentation error because big data is huge enough to handle with these kind of the programming language and the tools provided them for the big data analytics. But for specifically big data, if you go for the Hadoop distributed file system or Apache Spark or Apache Pig and the other platforms given to you, है ना, this could be done in a more efficient manner. So this is why big data we have kept as a out of the picture from this generalized picture I have given it over here. Is this clear to you?
Yeah, and data analysis and analytics, what is the difference you said?
Data analysis in the in general sense, you can say whatever the analysis I want to infer from the data. Analytics is the application of the tools to drive up with the important insight from the data. Okay, so analytics is basically performing or implementing the tools onto the data. Analysis could be in the in general summary, you can say. Okay, I have not used the specialized tools on the data. It's a just an important insight I gain now through the inferences also. But analytics involves application of the tools onto that data, techniques and tools basically.
Okay, and in data science, machine learning will also come, no?
Data machine learning actually is a very big domain. Okay, not every part of the data science will make use of every algorithms of the machine learning. Okay, some of the specific machine learning algorithms could be taken into account to perform the data science task. Okay, like data science, what I'm interested in basically gaining the insights from the data. For gaining the insights, I'm applying certain machine learning algorithms which becomes a part, and that is being bifurcated as a data mining, which comes under the category of. That's why if you see, some of the common approaches are there which also be there in the machine learning as well as in the data mining domain also. Like regression is a part of the machine learning also, as well as it comes under the data mining. As well as clustering, if you talk about, it comes in machine learning also, it's coming in the data mining part also. So they are out of huge machine learning algorithms, few specific machine learning algorithm is being used into the data science portion.
So data science mainly you say is statistics and all that.
Yes, probability theory, all probabilistic analytics, probabilistic analysis, prospective analysis, descriptive analytics, all this comes under data science.
Okay, ma'am, one more question.
Yeah.
You were talking about doing analytics on data of the size of 12 GB or something.
Yes.
So, where exactly do you store this data and how did you perform the analytics?
Yeah. Dear, that what I have practically done is I have in my laboratory I have worked on a Xeon based servers. Okay, so this is a specific Dell servers which is come for processing a huge amount of data. Right now, because of emergence of the technology and upgradation of the system, right now it comes with a name of rack based server. Okay, so these kind of servers basically has a huge processing power, nearly 500 GB of processing as a RAM. Apart from that, hard disk is in terabytes. Okay, so these are being connected with a one server node and various you can say slave nodes. So in that rack based server I create a Hadoop cluster, Hadoop distributed file system. So one will be acting as a master node, other will be acting as a name node. Okay, data node and the name node basically. So one will be storing the data and Hadoop distributed file system will be distributing that huge data into the multiple machines, and processing is being done in a parallel manner. Like for an example, 12 GB, if I consider, I have one master node. Apart from that, I have connected, suppose 11, you can say slave node. Okay, so 1 GB has to be processed by each of the machine. And that machine could not be of the same capability like a server. It should compatible with the server, but they could have a lesser RAM, lesser hard disk. Everything is would be feasible. Only
Okay,
minimum
so this
processing
is
required
again.
is the machine should be capable enough of processing 64 MB of data.
So these are servers with 500 GB RAM.
Yes, and the slave
Okay.
nodes for slave nodes also
Uh-huh.
is there with a capability of nearly about 125 GB of RAM.
Okay, okay. And so this entire server system approximately, what is the cost? Any idea?
This comes depending on how many slave nodes are being employed in that. Okay, so in my
Uh,
cases, actually, I integrated slave node one by one. Okay, so I reinstalled it again and again. But if you go approximately for 4 systems and one server machine, it will cost nearly about 20 lakhs rupees.
This is Dell Xeon.
Yeah, there's Xeon server, but right now it is being replaced with rack-based servers because rack-based servers are comparatively bit lesser in the price, and especially storage optimization is being done in that. In one rack, you can place all the servers. So if you go and for a good architecture, it will cost nearly about 50 lakhs also.
Okay, okay. So for Hadoop system in the setup in the lab, you
Yeah.
suggest one of these servers.
Yeah, one of these servers, because at least with a minimum requirement of Xeon based servers, if you go with,
Mhm.
they come with a 1 TB of storage, and at least they have nearly about, I think so, basic GB of RAMs comes out to be 64 GB. Okay, if you not go for
Mhm.
the expandable one.
Okay. Mhm. So that entire setup is 20 lakhs, you're saying.
Yeah,
Thank you very much.
okay,
Yeah.
welcome.
Ma'am?
Any other questions, please?
Yes, yes, ma'am. Am I audible, ma'am?
Yeah, you are completely audible.
Yes, I'm Pratika. I'm working as an assistant professor in CBIT Hyderabad. Actually,
Yeah,
teaching this subject, big data analytics,
yeah,
for the current semester. And previously also I taught this subject, but see, I have taken lab, and there we have we have done the distributed, pseudo distributed mode, not the fully
yes.
distributed as we are discussing now. So for the students, what we have done that for the single machine, we have considered as a name node and the data node. and there we perform the task. But can you please guide me that if we have suppose 30 computers in a lab and 1 TB of hard disk we have, and then can you please send any link that how I can make one name node and I can connect other
Yes,
data
sure.
nodes?
We have actually in my research group we have created one video and uploaded it on
Okay.
our YouTube. I will share
Okay.
the YouTube link with the
Please,
organizer,
ma'am.
and I will request them to share it with you all.
Yes, yes. So that students will be benefited, right?
Yeah,
Because they are
sure.
working like single device name node as
Yeah,
well as data.
we have created a web page also for that, which consists a
Okay.
description of how to do the installation. Apart from that, we have created a video also, so that I will share it with you all.
Okay. Exactly that slave nodes and name node management.
Sure, sure.
Okay. Okay, ma'am. Thanks a lot.
Welcome. Any other questions? So if you don't have any questions and still have the question, I am happy to answer that. You can refer to my one of the web page and can get the guidance in any related to this area. If you are feeling that something I can guide you, okay, you can look at my web page available at Mahindra University. Any other doubts, please?
Can you
Hello, madam.
suggest some big data related data sets?
Yes, in case of UCI repository, if you go there, you will get a data set of nearly about right now they have uploaded till I think so 12 GB. Okay, so University of Irvine, I think so everybody has heard of that. That keeps on uploading the data, which they do the testing in their laboratory. So I will show it over here also if anybody is not familiar with that. Okay, so this is UCI
Yes, ma'am.
repository. Okay, so there you will get various varieties of the data available. Okay, especially for an example, you are working in a healthcare system or medical or healthcare system or bioinformatics domain or any other data which you are, but might be for such a huge data. These kind of huge data is being available on the paid basis because I am working on a real life application. So I am in collaboration with one of the bioinformatics lab, so they keep on giving me the data collected on a real time manner. Okay, so they keep on providing me 80 GB of data, more than that, like that. So for that you have to look for a certain tie-ups. Any other
Hello,
doubts,
madam.
please?
Hello, madam.
Hello.
Madam. Can you highlight the applications of BDA in the field of agriculture?
Yes, I'm working on one of the domain of the agriculture. For an example, you have seen certain seeds are getting contaminated by the insects. For an example, soya bean seeds, if you talk about, I'm working on that. So certain seeds are very susceptible towards uh, drought as well as heavy rain, and they get easily contaminated by the insects. But as whereas certain seeds are susceptible to all these climatical changes. So I am performing that study, that what is the genome sequences of those particular seeds which are not which are not susceptible to the climatic change and still resist, so that I can make those seeds which are easily get it contaminated also susceptible to the climate change. So I collected the genome data and do the clustering over that data using Hadoop scalable clustering algorithms, and these works you can refer of mine which specifically on genome based study. So you can keep on referring to the Google Scholar page where you will get that I'm working on these area which actually make use of the genome study. So this is a particular scalable algorithm which we have designed for actually parallelly processing the genome data only. And this is in general also applicable. So we create a cluster of which seeds are better quality and which seeds are getting contaminated. Okay, so to find it out the interesting pattern so that we can change the genome sequences of those seeds and can make them also resistible towards the climatic change. This how we can increase the production of a particular. If I'm talking about the soybean seeds, this leads to increase in the soybean production.
Madam, for that, have you taken the real-time data or any
Yes, I have taken a real-time data from Indian Council of Agriculture Research. One of the institute is under that Indian Institute of Soybean Research Center. So I'm working in collaboration with that institute.
Thank you.
Any other doubts, please? For collecting such huge data, you need to collaborate with any medical hospital. If you are working on a healthcare data, they keep on providing you such a huge amount of data based on how you provide the solutions to them.
So this Indian Council, how are they collecting the data using sensors?
Actually, they have the laboratory. Apart from that, they have implanted the sensors in the agriculture field. So, what is the content of the soil and how much is the seed quality? They keep on getting the data. Apart from that, they do the medical laboratory based analysis also. But to come up with any drug through the laboratory based analysis take lots of amount of time. So they want a intelligent machine learning algorithms to come up with such these kind of interesting insights, so that rather than investing so much time in the laboratory, they can make use of these intelligent algorithms and can come up with a quick solutions for the problem. Does it answer your question?
Yes, ma'am. Thank you.
No. So if you have further questions, please keep on writing to my email ID. I think I have shared it with the organizer, and I'm also writing it here so that if anybody is interested, can able to see that. Okay. Okay. So you can drop your email on this email ID if you have any queries further after this session also. Thank you all for paying an attention and asking wonderful questions. So I have any more further questions?
Yeah, madam. Thank you very much, Dr.
Okay.
Neha.
Thank you so much, sir, for organizing a talk and giving me the chance to come up in the interaction with all the participants here.
Yeah, it was a wonderful talk, madam.
Thank you.
I hope that the participants have really got benefited out of your talk.
Yes. Thank you.
Thank you.
Okay. Thank you, sir.
So I think it's the time to wind up this second session. So tomorrow we can join at 10:30 once again, the second. Thank you all. So I request all the participants to post their attendance. So in the chat box, I have posted the link. So every session you need to post your attendance.
Sir, I got a problem in while submitting the attendance. It's showing the time. If I mentioned 4, it is not accepting, and if I mention 16 also, it is not accepting. Can you give me the solution?
Yeah, you can just leave, madam. I'll just yeah, I in another 2 or 3 minutes I'll just adjust it. So okay, I'll just adjust it.
Okay, sir. Thank you.
Okay. Yeah, madam, you can simply skip that.
Sir, but it's showing as a mandatory field.
No, I just changed it as a non-mandatory field.
Okay, sir. Okay.
Once, please refresh and submit once again. Okay, madam.
Can you please resend the link because due to some network problem I was disconnected.
Yeah, please, please hold on, sir.
Sir, for the morning session, I was present, but I did not see the link. So I have not marked the attendance.
Yeah, okay. Morning, I did not give the link. I have taken offline, madam.
Okay, okay.
So I have just
So from
posted the link. Can you please
okay.
verify?
For the afternoon session, I have marked.
Yeah, morning session I have taken offline, madam.
Okay, okay. Thank you, sir. So I can leave now, no?
Yeah, madam. Thank you.
Okay, thank you.
Yeah, can I conclude this session? With your permission, can I conclude this session? Can I close this? Yeah, thank you all once again. So hopefully we are joining tomorrow.